Hello everybody and welcome to 50green.com. This is number 3 out of 4 of the Portland sessions. And today we're going to continue on with our green home tour. I've got to say that I've always enjoyed looking at good architecture, good buildings around the country, around the world, any place I travel, and the green home tour has been a lot of fun for me. You really get to check and see what the different practices are in different areas, different climates. Everything is unique. There's not one green style for everybody. But in continuing on, last session we did the Lone Fir house and the Harpoon house. The Lone Fir house was a really interesting example of passive house techniques in construction, so we could really see a lot of what was going on there. We also looked at the Harpoon house, and we talked about some building science, some building technology, how things work the way they work. Today I've got the final 3 homes for you in Portland, and then we're going to zip on over to Hood River for the final session. But today we've got the Curtis House, the Living Commons or the Commons, and Vermont Street. Ton of information today, so we're going to crank it out quickly. Put on your safety belts. Here we go. Okay, the Curtis House. This was a very interesting house. I ended up talking to the designers who were there for quite a bit. Super high efficiency house. Got a lot of natural ventilation, a lot of daylighting. Used a lot of salvage wood. You can see this wood here apparently came from a mental institution in Portland that was salvaged. This was done on a very strict budget. And it's a fairly small house. It's 1,400 square feet. And I believe there is also a apartment or another dwelling underneath it, so it's actually 2 dwellings, which gives us a higher density, which is another green technique. It's got sort of a loft style layout. I think the guy is a musician or a music producer or something like that. Very straightforward. A lot of high-tech mechanical systems. This is a shot from across the street, and here's an interior shot. You can see this big open loft space they have. There's a piano over here, and this kind of cool yellow spiral staircase which goes up to the master bedroom loft. They used a lot of materials here that are very durable and low maintenance, and we're going to talk about the siding here in a second. They also used radiant heat and a on-demand instant hot water heater. This is that loft space that you can see from down below here. This area up here, you can see kind of the unique joinery that they use, bolting these big beams together. Another shot of that salvaged wood, and they have this is sort of a rain screen technique over plaster. Again, we've got some gaps in here. We've talked about that. This material here is hardy board. We use this stuff all the time. It's fiber cement. This is another sort of a rain screen technique. There are sleepers underneath here, which you can see the nice stainless screws that they used in a nice fashion here, very orderly fashion to attach this siding on, and there are some gaps which allows any moisture which passes through this rain screen wall to evaporate very quickly. There's another shot, and I wanted to show you, as a matter of fact, Hardy, the company James Hardy, and this is from, there you can see their name up there, James Hardy. This is from a building show. They actually have now, I think because architects and designers were using big pieces of their panels, this is their more typical siding here, a lap siding, which would be comparable to the look of clapboard. They also have this so that it looks like shingles and a number of other sidings. But this sort of big square look here was invented by creative building designers. What you see here is there are simply sleepers over the building, and then this is attached. So there are these openings here which allow the wall to breathe nicely, but also allows moisture to pass through there. The new technique that Hardy, and this a couple months ago, this was only available for commercial buildings, not residential, although I'm sure you could probably get it. It's actually a thicker panel. I think it's a 1/4 inch thick instead of an eighth or whatever the regular stuff is. Anyway, it's a bit sturdier, the panel, but when you see that panel in the previous picture, what happens is the panels are stuck together, and much like we did on Casa Verde, if this is the outside, this is the inside, they have a flashing kit which provides a metal. So you have your building paper that comes down here, and then you have a little piece of flashing which comes in and overlaps the outside. Then you have more building paper and another little piece of flashing that would do that. So as we know, water is always forced to the outside. So any water that hits this wall is, or even gets behind it, is always going to be pushed to the outside rather than the inside. Just like a duck and its feathers, it's always important to layer to the outside. Okay, seems like we've had a bunch of different toilets, a bunch of, what else could we call this? A loo, wastewater. And this one is high technology. This is a Toto washlet. Talk about technology. Here's the control panel. Here's the toilet. This little control panel has, as you can see, special buttons for cleansing from this angle, cleansing from this angle. There's a dryer. There, I guess you can adjust the temperature. Interestingly enough, and I see these more and more in houses, and apparently they are quite popular in Europe, but this is the advertising that Toto has on their website, and you can see clean is happy and green is happy. So apparently these toilets actually use very little water, and they also claim that by using this technique, of course you don't have to use toilet paper, and through an independent study that they quote, an average family of 4 uses 183 rolls of toilet paper a year, or 1.3 trees. This little toilet seat has automated sensors that use aerated warm water for cleansing instead of paper. And it also is very water conscious as well. So I haven't tried one myself, but there you go. Alright, this is the stairway. Caught my eye in the Curtis house. They had this inlay here. These are Doug fir treads here that were salvaged, and then they put this nice little inlay into the stairs of a lighter wood. Alright, moving right along to the living commons. This house is very interesting, and it is being built slowly. There's two brothers who are doing what's called the Living Building Challenge, which requires that your house is net zero, requires that your house collects all its water. I think it also requires that all your materials are locally sourced from within a certain radius. But you're looking at the back of their building. It's sort of the floor plan is something like this. There actually was an old building. Here's the front. So we're looking at this back side right now. And you can see this house has a lot of glass, and it is completely coated with this material here. Okay, so you can see here that this is called Protecto Wrap SAM, self-adhered membrane. I guess they provided it for no cost because it says sponsorship. These little notes are all over the place on the green building tour. This is waterproofing and air barrier. The house will be extremely airtight as a part of thermally efficient envelope. During colder months, we will deal with moisture and air exchange through the use of an HRV, which is in the mechanical room. So we've discussed HRVs and ERVs. This Protecto Wrap has a perm rating of 0.01, and that means it's impermeable. 0.01, and anything less than 0.1 is qualified as impermeable. So that's like plastic. That means it holds water. The higher up the scale, the more permeable. This can have interesting effects on the total vapor profile. So any water from the inside will not pass through this, and any water from the outside will not pass through this. So any water that gets into the wall will have to be removed inside or outside. It can't pass through. It's going to hit this barrier right here and not go any further. You can see they also used vinyl windows. We'll talk a little bit more about those. Okay, some unique steel framing, steel stud framing. You can see all these steel studs in here in combination with wood plywood, and they used these trusses up top here. You can see it's a solid 2x on the top with the metal struts that work those trusses. So I'm not sure what the insulation will be in here, maybe cellulose or fiberglass batts. And on the outside, you'll see that they have quite a thick layer of foam. As a matter of fact, they have 2 layers of this RMax, EcoMax product. And this is a rigid foam. It's a closed cell, what's called a polyiso sanuret foam bonded to reinforced aluminum foil facers on each side. So I looked up the perm rating on this stuff too, and it has a perm of 0.3. When we go from 0.1 to 1, that's called semi-impermeable. So it's still pretty much waterproof. We went from the Protecto wrap at 0.01 to this, which is 0.3. It's still quite impermeable. And the insulation of this it's 3 inches thick, and it equals an R17. So we've got 2 layers of this equaling 6 inches, or that would be an R34 wall, plus whatever they put on the inside. Now, interestingly enough, you can see here's a broken window. Sometimes happens in construction. But look at the thickness of this wall here. They've got 6 inches on the outside of these windows. So particular care needs to be taken in this area, because this is called a shelf. So water, kind of a notorious leaking spot for production type buildings, or all buildings I should say. And this, because water can settle on this, basically it needs to be treated like a roof, and this needs to be waterproofed quite well. So I'm not quite sure what their technique is going to be for this. The other challenging thing is, depending on, and I don't know how they're going to handle the siding, but depending how they handle the siding, you can see this is already 3 inches thick right here, and they have these spikes coming through. So they've got to secure this to the building. Whatever the siding is, I'm imagining they're probably going to put some sort of a lath on there, which they'll bolt into the sheathing, and then they'll use some sort of a rain screen around the top, would be my guess, because that's what we've seen throughout Portland. You can see they have a nice metal roof up top. All right, let's take a look at their vapor profile. If we look at this being the outside, we've got 2 thick layers of foam, 3 inches each, for a total of 6 inches. Then we have our Protecto wrap. I'm going to make this a squiggly line here. That's the Protecto. Then we have our plywood siding, and then we have our metal studs. And whatever our insulation is here, we'll signify that by the standard insulation. So we've got an extremely thick, let's see, 6 inches plus another 4 inches. We've got at least a 10-inch plus wall, right? By the time you add siding and drywall and everything on there. And we know that this is already R34 with this foam. So if we add another 10 or something like that, you're going to have an R45 wall minimum. So he's got extreme insulation. It's extremely well air sealed. What I'd want to look at is the vapor profile and what happens with the temperature. We've got high humidity in Portland, so we'd want to know where that dew point, if we figure 70 degrees inside and an average winter temperature of whatever it is, 30 degrees outside, we're going to have this vapor profile, which we've seen on some of the other walls, and we're going to need to find out where the dew point is. Very important for this. So maybe we'll see at the tour next year what they're going to do. Okay, this is very interesting because the owners put up this little note card here, and the windows are from Serious Materials. I'm not familiar with this particular window, but they spent 70 grand for their house on windows, and they chose them because they determined that these were the best performing windows for a price. Then they noted here, poor build quality, terrible customer service for end user, fixed order 4 times and still incorrect. So obviously they're not very happy with these particular windows. As we've discussed quite a bit, windows are very important because they are the holes in this highly insulated envelope that we've created. We've talked about vinyl in the past as well, so I'm not quite sure. You know, obviously they have a budget and they're trying to do the best they can for this house, and this is what they chose, and I think they are unhappy with what they did choose in this case. All right, I loved this. This is actually their stairway down to the basement, and this is called a Jefferson stair attributed to Thomas Jefferson. You can see there is a tread on one side and a tread on the other side and a tread on this side. They alternate, and what this does is it allows you to condense the space, because whenever you're designing a building, stairways take a lot of space, not only for the width but the length, because of the length of each tread, and the max rise, which is usually 7.5 to 8 inches, means that a typical 8-foot stairway has something like, or an 8-foot ceiling height would have something like a 12-foot long run to get a stairway in. So in other words, if you had an 8-foot high ceiling, you'd need a 12-foot by 3-foot space to stick your stairs. Anyway, this particular stairway, as I mentioned here, you can't use, it's only legal in non-living space. So it was legal for them to put into the basement, but I thought it was pretty cool. Another shot of the stairs. You can see the banister. This is going into their basement. Okay, so this is interesting to me. They used a concrete floor, solid concrete slab. You can see it here. It's probably 3 inches thick. And this is one technique of making concrete slabs. This is you generally see this in commercial, but you have a steel decking, which comes like this, goes down and up and down and up, and it gives you this strength to pour the concrete on top of it. Usually you brace below. I'll show you there's another shot from underneath it. But for me, I like using slab on grade with radiant heat, and when you get to the second floor, and if you're wood framing the building, it's challenging to do a concrete slab on top of wood. So this is a way that you would do concrete on top of concrete. And I'm not quite sure what their basement is also concrete, as you can see. And this was a shot looking up through a cast iron piece that they had, and the patterning of these sort of star shapes. So what they have here is a composting toilet. And you can see the detail here. It's a Phoenix composting toilet. This particular toilet cost them $6,000, and they say that this is one that is used in the national parks, and apparently it can handle 8 people continuously. It's quite a big monster that's down in their basement. I think there is some requirement to shovel some sort of composting material in there. I'm not exactly quite sure how it works. Oh, there's a lever here that you got to operate every once in a while. So it does take some upkeep. And you can see their site at, that stands for Residential Community something, rescommunis.org. They have a little bit of a blog. Okay, our final house in the tour in Portland, Vermont Street. This building is a building after my own heart. The owners, Jonathan and Maxine, actually own a couple of companies. One is a company that designs energy efficient homes, and the other is a company that salvages timber. And they have outfits both in New York as well as in Oregon. But what I saw here was a really strong knowledge of building, and he used, it's quite a sophisticated building in a small package. He used a wide variety of building techniques. He used timber frame. He also used SIPS panels on the roof, but he used a sort of a hybrid wall on the sides, and he used ICF down here for his basement walls. He used radiant heat. He also used high-tech European radiators. And as you can see, we're going to show you some more details on this, but this is solar hot water, and he's also got solar electric panels up top. And I like it because even though it has some sort of historic references, it's a very modern house. Another shot of it below, you can see they have raised garden beds outside. And here's a green technique: hanging your clothes or hanging your sheets outside instead of using a dryer. So he's kind of got, it's on a sloped site. He's got a sort of a walkout basement area here below. And you can see the beautiful timber framing that he used. Again, if you look at this clear story windows up here that let a lot of light into the house. And here they are again. And you can see his timber frame. He has these big trusses here, and then he's got a sort of a pitching shed that comes up and allows these windows to be put in. He uses fans. He's got some high ventilation up here. I'm a huge fan of timber frame, which you don't see much in California because of our engineering criteria. Usually when you do, it's largely a timber frame that is only decorative inside of a building and not structural. But not only does he use timber framing, but he uses salvaged timbers. These are all timbers that come from old factories and old buildings that they've dismantled and repurposed for this home. Now, there's lots of detail shots here, but you can see this is actually an arched truss. Now, when you look at these trusses come in all kinds of different shapes, but this is subtly sophisticated here. He's got an arched truss. You can see this gentle curve that goes in here. Here, this is what's called the king post. And in timber framing verbiage, each one of these sections is called a bent. You can see there's a post there, and then there's a truss above it. There's a post here. It goes all the way down the building. Trusses can come in all sorts of different fashions. A typical kind of truss would be something like this with the king post. You can also have trusses that cross. They call them scissors trusses. So the roof would be up above, and the trusses cross in the middle. You can also have what they call bent hammer trusses, using massive pieces of wood. Old buildings that I used to work on in New England were actually built this way. The early log cabins were a sort of a timber frame, and then as they started to figure out how to work the lumber better and got better tools, they would, instead of using round logs, they would use adzes and other types of tools to square off the timbers, and then they would create structure out of these timbers. This is called post and beam generally. You have, as the language states, you have posts, and then you have beams coming across, and for a roof you have these trusses, which can be designed in a number of different ways. Timber framing involves mortise and tenon joinery, and that means that the interlocking pieces of the timbers will be put together in such a fashion so that a piece coming in here, you would have a mortise or a cutout in one piece, and a tenon, which would be the solid piece from this beam here, going into that mortise. And that's what helps keep all this together. Obviously, this all used to be done by hand. Today, it is done, I believe Jonathan has what's called a CNC, a computerized machine that creates these perfect joints. You can see here. There's a slight bird's mouth for this mortise, and you can see the splines and the pegs that hold these together. These are oak. Use a more dense wood for these splines and pegs. Another shot, you can see here's a little shelf that this beam sits on, cut into the post. And there's a variety of ways you can do this. This is a actual woodworking shop I attended years ago in San Diego, put on by Will Beamer, who's the president of I think he's probably still the president of the Timber Framers Guild. And we did everything by hand. We can, as you can see, these old mortise bits, these drills, we cut out the mortises, and they're in all different shapes. This is what you would call a CNC machine that they would use today for highly complex. You can see this is a curved beam, and it has a number of cutouts on it. And these machines, there's no people involved. They send saws out on these computerized arms, and they cut out exactly what they need. The old kind of tools, you would have things like mortises and chisels and slicks, different kind of literally sharpened steel knives, draw knives. You would have wood mallets, you'd have adzes. This is a collection of different connections that we're using for a building. You can see these very long tenons over here. And this on this beam, and a variety of mortises with shelves on them, all different kind of things. And this is put together to create this particular sculpture, which they even carved the date in 1999. You can see that's Will Beamer. This is yours truly working on a old-fashioned mortising jig. So you would set that up, and it would help you drill out or hollow out the mortises on the beams. And you can see there's a wood mallet. Another shot. And you can really create beautiful structures by hand. as well as with these CNC machines. And I was happy to see in the basement of Jonathan's house, he had some of his timber framing tools right here. You can see some slicks and some big wide chisels. The CNC machine, I'm sure, is at his factory. So this is the website, and you can check this out for yourself if you like, newenergyworks.com. This is the Vermont Street project. You can see some nice renderings of this project. And also the Pioneer Millworks is the company that's just some gorgeous, you can see the steel straps. This is what you call a hammer truss, where it's interrupted here with this arched brace. I think that stuff's really pretty. I had a number of different woods in this house. This is Douglas fir. You can tell by this orange color with a very distinctive hard and soft grain that Douglas fir has. The darker grain is the harder grain and the whiter grain is softer. Makes it sometimes a tricky wood to work with. But they use high-tech, highly insulated windows, and they used a very traditional sort of casing with there's a bead here. You can see this is a bead, and then a flat stock casing. I think it's very elegant. This is some little LED light detail that they used alongside their beams. Here's another shot of, I think this is oak, but it's obviously very rough. That you can see the saw marks on these planks, and this was probably from some sort of factory floor or something like that. But this is just one floor in an office, and they left it rough on purpose, and I liked the texture of it. Here you can see a shot looking down towards their kitchen. This is a custom island here made out of salvaged wood. You can see more of their beamwork, obviously, and again those high windows up top that let a lot of beautiful light into the building. Another shot of this island table. You can see this very nicely pieced together, and I'm guessing that's probably oak there. But a lot of thought given to this kitchen. I believe this is a magnetic induction cooktop, which is sort of a cool thing. You have to use pots and pans that are flat, and this is several steps above those old style electric things. Look it up, magnetic induction cooking. And I really love this. Here's a table that he obviously built, and you can see this is a raw slab cut from a tree. There's the bark side, and the tree had some sort of a trunk that came out here. They left a very natural shape. The famous furniture maker George, I think it was Harakawi, used to design tables sort of like this. But here they have a very milled, heavy beam type piece, which you can see comes up and cuts right through the top of this table. I thought that was very attractive. Even the bathtub, there's a cast iron tub right here, but they coated it in this beautiful wood. Now, as I mentioned, he used radiant heat, the tubes in the concrete slab in the basement, but they used these. These are also radiant, but these are radiators, and this is, I think it's Runtal is the brand name. This is a European brand, and because he has such a highly insulated and well sealed house, he doesn't need a whole lot of heat to control he doesn't need a whole lot of horsepower to heat this house. As a matter of fact, he told me that this was too much and he may take one of these out. It's very interesting. He provided an example of his wall envelope. You know how we've been talking about vapor profiles and actual details for the walls. Although he used SIPS panels on the roof, which are the plywood on two sides with sandwiching foam in the middle, he did not use SIPS panels on the vertical walls. And part of the reason for that was he felt it worked better with the construction and the openings that he was doing. So he framed the house with 2x4, as you can see here. Then he put a sheathing over the house, which gives it a lot of strength. We often need certain kinds of nailing, and the sheathing is very important for the structural rigidity of the house. So he used that for his vertical walls, and then he sandwiched that with a layer of foam all the way around. And what the foam does is it surrounds the house and gets rid of that thermal breakage of the 2x4s that we've talked about. So he's got he's sealing the building very well, and then he's coating that with a breathable fabric. And then he's got this looks like some kind of a treated piece of lumber as the runners that are put on the outside. You can see a very nice sealant. The window paper is lapping over the building paper. And then he's got a rain screen design, as we've seen before. So he's got a space in here, which is important. But look at his rain screen. His wood is lapped. It's called a ship lap. So each piece has a little joint like that, so that the next one comes down like this. So as we know, any rain coming from the outside of this is going to hit this wood. It's going to run down, and it won't very likely travel in and up and through. But even if it does, it still has a way to get out through the bottom here. So rather than leaving a space, you can see this nice profile of that shiplap right there. I thought this was a very well thought out rain screen. So again, he's got 2x4s, which he used cellulose insulation in there. Then he's got his structural sheathing, plywood or OSB, and then he's got a layer of foam. He's probably got some sort of a sealing paper here as well. And then he's got his sort of material here that works like Gore-Tex, and then slats, and then the rain screen, of course, with the little doodads. So he's got a great rain screen, and this wall allows evaporation to occur both to the outside and to the inside. Very effective, very well done. This is the boiler for his whole house. As you can see, it's obviously a sealed combustion unit. It's very compact. This is a pump here for the radiant floors. Then he's got solar, or the hydronic hot water. This is the unit which, when the solar panels up on the roof heat up to 10 or 14 degrees higher than what's in the tank, they kick on and they start circulating the water, which heats up this insulated tank here. And again, this tank probably provides domestic water, and may even circulate through the radiant floor as well. You can see his ERV or HRV, I'm not sure which in particular it is, which brings in the fresh air and moderates or tempers the cool air coming in to closer to the building air. Right here you can see these huge water tanks, and he has on his site an interesting rainwater harvesting catchment design that he hasn't put in yet. I believe these are to be set out in the yard. So here's a shot of the outside. Here's a shot of the outside. This is a salvaged, weathered barn siding type material. You can see he's used a very high quality clad window here. And his rain screen is actually made out of red wine barrel slats. So they have all these slats that they remill for that siding that I just showed you. Very beautiful natural color, and you can see how he trimmed out around these windows. Here's a shot from the inside of a rafter tail. You can see he's got a thick rafter, probably a 4x rafter here, which has this detail cut into it. And we're looking through the screen here, but you can also see in the outside there's that same detail right there. And as you know, I love the metal roofs. They're great for water collection. They also reflect the sun's rays. And one thing I particularly liked is he really shows off his solar. So instead of trying to hide it or sort of be ashamed of it, he designed it in, so you can see how neatly it fits on this roof. And I really like that. Instead of ending up with an odd-shaped amount of panels, that kind of came here and went over there, he's got the whole thing filled up with panels. I don't know if he needed exactly that number of panels, or he added one or two just to make it fit, but it sure looks good. Same thing with his hot water. It's just got the 2 panels here. This is very similar to the system that we used in Casa Verde. Very beautiful lines, very well flashed and detailed out here. You can see all the different parts and pieces that they used. Another shot of the roof. Another shot of his raised garden beds. There's some lettuce ready for picking. And then he also built this is a little guest house right next door to it. This is a beautiful redwood railing. You can see these beams here. These are salvaged beams. These are the old malleable washers that they used to use in heavy beam construction. They look something like this. You see them in factories and so forth. And they were there. They were used because they beefed up the strength of bolts when you use that thick, heavy washer. There's a detail of that redwood siding. So here's the approach to the house. This is a brand new house, so you can see they're still finishing up. They've just put these trees in. And this is the main house here. You can see it's sort of got a T shape. The main section where the kitchen is in this area, and then there's this T that runs perpendicular to it. A little piece of a second story up there. This is their guest house. Okay, so what's next? We've got one more session with our Portland sessions. We've got the Hood River session. And coincidentally, after I went to my Portland Green Building Tour, there was a Green Building Tour in Hood River, along with the annual Hops Fest, which is a delicious beer festival I attended. With the incredible beer from Portland, the Oregon area. But Hood River is also the windsurfing and kite surfing capital of the universe, I think. It's a very cool place. So we're going to take you through a couple green homes and tell you a little bit about Hood River in the next session, which will be the last of our Portland sessions. And above and beyond that, we are already working hard on the ICF sessions. ICFs mean insulated concrete forms. It's a very interesting way to build. We're about to start a project using ICF technology. So that'll be coming up after the Hood River session. Once again, if you have any questions, please email us at 50green50@gmail.com. One dot, not two. You know where we are at 50green.com. We've got lots of interesting information on our blog as well, including the 50 Green TV series that we've been working on. So this is Otis Bradley signing off. I look forward to seeing you on Portland session number 4 and all our other sessions coming up in the future. Thank you very much.